Sunday morning in the Tokyo district of Akihabara. It's the place to go for Japanese youths, mostly boys, to check out the latest games and technology and to get away for a while from the pressures of studying. Across town in Harajuku, teenagers, largely girls, are expressing themselves through fashion in ways that their parents probably find quite disturbing. While some things stay the same, the bustle of the Tokyo fish market, the tranquility of a Buddhist temple, the crowds at Shibuya Crossing, much is changing in Japan, and this is as true in the field of science education as it is for other areas of Japanese life. In the UK, we have a view of Japan and science derived from the legacy and legends of Japan's economic miracle in the 60s and 70s, an image of a country of constant innovation where young people are naturally drawn to science and technology. In fact, Japan now has similar issues to the UK when it comes to encouraging students to study science. Sanae Kawanabe teaches science part-time at Koenji Junior High School in Tokyo.
Children are shying away from the sciences in Japan. I do feel this is a trend. More and more children are poor at thinking about things in depth and wondering why something happens the way it does. The children want the answer from the very start without paying attention to the process. And once they get the answer, they are not interested anymore.
Today, Sanae is teaching a chemistry practical to a mixed ability first-year class of 12 to 13-year-olds.
Today's class is about how powdered solid objects dissolve in liquid. Even though you can't see the dissolved material, in this class we are going to find out what actually happens to it in solution. Within the 3 hours a week given to science, typically one is used for experiments, while the other 2 are spent preparing and explaining, and making notes and drawing conclusions after the experiment.
The class enjoy the practical task, and Sanae expects them to work well together and work things out for themselves. But they're not all sure that when they get to high school, they'll be choosing science.
I have 2 favorite subjects, which are Japanese and music. I like music because I feel a sense of accomplishment when I play a song without making any mistakes. I like most aspects of science, but I don't like the calculations.
I don't think I'll be specializing in the sciences. This is because I don't like the sciences very much. I don't like making mistakes during the experiment. And also, we are handling dangerous poisons. That's why I don't like science.
An hour's journey from Koenji across the Tokyo River on land reclaimed from the sea, the futuristic landscape of Odaiban is home to the Miraikan Museum of Emerging Science and Innovation. The brand new museum has a mission to revive enthusiasm and passion for science in Japan. In partnership with the Ministry of Education, the Mirai Kan Centre devises exhibitions and outreach programmes to help school teachers motivate their students to consider a career in science. Dr. Noriyuki Inoue is responsible for building relationships between the museums and schools.
科学技術または理科については、みんながやはり普通の生活を送る上で
It's important that everyone has a basic level of knowledge about technology and science in everyday life. This relates to anything from choosing medication to driving a car.
生徒自身が将来の必要を感じ
Pupils need to see science as something which is essential for their future.
中学高校の、科学に対する
Students are most concerned whether the topic will be something which is covered in their entrance exam, but we are trying to change this attitude so that they study because they are interested and to make the experience more fun.
これにつなげて楽しいものに変えていきたいというのが私たちの活動になります。
At Koenji Junior High School, Japan's falling school rolls mean that Kimio Ogawa is now their only full-time science teacher. His mixed-ability third-year class of 14 and 15-year-olds have been studying the movement of the sun.
I try my best to have as many observations and experiments as possible. The percentage is about half. I'd say half is time allotted for experiments, and the other half is to gather notes. This is because I think it's very important that in science, you start with experimentation and end with experimentation.
大切なことかなというふうに思っているからです。はい、お願いします。透明半球状の今日の授業なんですけれども、昨日
Yesterday, we conducted an experimental observation of the movement of the sun. Today we'll be organizing those notes. We looked at what sort of rules the sun follows, and based on these rules, we are trying to estimate the time of sunrise and
推
sundown.
定するという学習を行います。中学校の3年間で勉強することは、
What's covered in the 3 years of junior high school includes a balanced education drawn from 4 subjects: earth science, chemistry, physics, and biology.
4つをバランスよく学習します。日本の勉強の中では
In the
太陽
Japanese
の動きという
curriculum,
の
the
は
movement of the sun falls under the discipline of earth science, which also includes space, weather, and geology.
それから地質ジオロジー。
Very soon, these students will choose their high schools and begin studying hard to get into them. How do they feel about science?
My favorite subject is maths, because once you remember the formula, you can solve anything. This is different from social science or history, which I'm not very good at because there's too much memorizing. I'm not going to choose the sciences. They're too difficult. What's inside my head is first of all how to get into the high school, and then about my boyfriend.
こんなような感じになると思いますけれども、
僕は理科がとても大好きです。
I like science very much. This is because it becomes a lot of fun when I am doing it, and the time just seems to fly
時
by.
間が経つのを忘れるからです。
透明半球の上を
僕の他にも男子は
Like myself, most boys like science, whereas girls don't so much. I think girls probably like the arts better.
文系の方が好きだと思います。
私たちの教える
The basis of our teaching comes from the course of study provided by the Ministry of Education, and I don't think there has been much change to this. Rather, I think the attitude in the teachers has changed, from cramming information into the students to encouraging them to think for themselves.
ということがあると思います。
The Japanese government researched the lack of interest in science in Japan and identified the 3 I's: interest, information, and incentive as the key issues to address if Japan is to attract and nurture the creative scientists it needs to maintain its global reputation as an innovator in science and technology.
1つ目がインタレスト。
The first was interest. Even looking at how children interact while playing video games, there wasn't much interest in investigating things or getting to know anything in depth.
2つ目の
With information, it seemed that there was not much opportunity for scientists to explain things to the general public, and the subject was not taken up very much by the media.
またメディアで取り上げられるようなチャンスも少なかったんです。で、3つ目のインセンティブ。
As for incentive, there was a general consensus that even if you work very hard and enter society as a scientist, the rewards were very
報
few.
われない仕事しかないんじゃないかと。
Responding to this research, the Japanese Ministry of Education encouraged schools to develop links with real scientists in research institutions. One institution that's made itself available for such links to schools is the Tokyo Institute of Technology, one of the most respected science universities in Japan and home to one of Japanese science education's secret weapons. These undergraduate students of chemistry are presenting the results of their research to their peers under the watchful eye of Teijiro Ichimura, Professor of Molecular Spectroscopy at Tokyo Tech.
We are doing the molecular spectroscopy. It's a kind of the physical chemistry, and it's a kind of the interaction between the molecule and the light.
But Professor Ichimura has a double life.
I'm the professor of the molecular spectroscopy at Tokyo Institute of Technology, but I'm also the principal of the Tokyo Tech High School of Science and Technology.
There are 101 super science high schools in Japan, which students enter by competing successfully in a public exam. The Tokyo Tech Super Science High School was formerly a vocational technical high school created to educate technicians who did not go to higher education. Since its designation as a super science high school, it's been able to design its own curriculum, a winning synthesis of practical engagement and academic knowledge. Over 80% of students now go on to four-year courses at university.
The Ministry of Education started the Super Science High School program on 2002. And at that time, the many normal comprehensive high school are just focusing on the understanding ability. In the case of our high school, we are adding to the understanding ability, practicing and designing abilities. Okay? These two abilities are very important for the becoming the talented scientist and engineer. We reorganized our educational program at the 2005, and we added the ability to challenge and also ability to convey ideas.
当然質量が重くなるからこっちが M1 ですね。でこっちが M2 だよね。
Each of the 3 years at Tokyo Tech has over 200 students.
でもう一人ねちょっとストップウォッチ測る人じゃあここまで乗っちゃっていいよ。
In the first grade, there are 5 classes of 40 students. And for practicals, each class divides into 4 groups of 10. Today, Takayuki Imada's first-year group are in the physics lab, looking at gravity and acceleration using 2 different methods as part of their Foundations of Science and Technology course. Also helping with this lesson is teaching assistant Misato Kosuge, who specialises in helping students with practical experiments.
これですね、実験装置ここに組んであります。それでですね、上にさ、この黄色いシールベタベタ貼ってあるの分かりますか？
実験の概要ですけれども、今2つに分かれてるんですけれども、基本的に
The experiment is based on the theory of the acceleration of gravity, and there are 2 parts to the lesson. One group is measuring the speed of acceleration directly. This is a bit difficult to measure manually, so a timer and a sensor are used to help.
それで測定を行ってます。で、もう一つの、奥の方の、
The other experiment uses a more low-tech method.
それでこの赤い光をメモリに当てます。実験方法が変わることに。
Through using more than one method of experiment, we encourage the pupils to explore the reliability of data.
生徒たちがこの少人数でやっていること。
There is a significance in the children being placed into very small groups, as this allows each student to take an active responsibility.
ただ知識だけですと。
Just knowing something does not allow you to apply that knowledge. From early on, we greatly encourage practical work, which will be useful for their future careers when they come to make things or do research.
The
main reason for choosing this school is because it is a designated super science high school and a place where one can study cutting-edge science and technology. Also, it is much more affordable than a private school because it is a national school.
This school used to be a technical high school, and now we are trying to build a bridge between practical skills and academic knowledge. We are unique in the sense that we nurture our students to think creatively and help them to reach goals themselves, rather than bombarding them with trivial knowledge like most ordinary high schools. This is what makes this school different from most others. The first-year students at our school are not divided into specific subject areas. Rather, the syllabus is designed so students can make connections between all of the subject areas.
In the first year at Tokyo Tech High School, students study core subjects like Japanese, English, social studies and maths, but devote more time to science. They study the foundations of science and technology, divided into 5 themes: applied chemistry, information systems, mechanical systems, electricity and electronics, and a 3-dimensional design or architecture course. In the second year, students choose to study just one specialist science area. These 16 and 17-year-olds have chosen applied chemistry, and their class of 40 has been split into 4 groups of 10 for a weekly 4-hour practical. Last week, they made aspirin, and Masaru Moriyasu is demonstrating how important it is to get a pure product.
I first became interested when I did a summer holiday science project in elementary school, but I really became interested in the subject when I was in my second year of junior high school. My dream is to become a pharmacist, so I decided to come to this school to study.
This week they're investigating methyl salicylic acid.
Well, we've combined salicylic acid and methanol to cause esterification. Then we'll extract salicylic methyl and refine it. This is today's objective, and we are currently at the stage of extraction. When this is completed, we use distillation to obtain the final product.
When I was about 14, I saw in a book that this school was well known for its football team, and also found out that they had a good academic program, so I wanted to come here. During junior high school, I didn't have the chance to do very many experiments, but I thought that if I came here, I would be able to do a lot of experiments, and that sounded like fun.
We have completed the extraction from the reactive compound and are now dividing the solvent and the methyl salicylic acid through distillation. So we are at the final stages of the experiment.
There are quite a few girls in applied chemistry and architecture, about 10 students each. But there are not very many female students in the other fields, and even in other schools, there seems to be more female pupils in applied chemistry and architecture. That must be why it's like that here too.
Tokyo Tech Super Science High School's emphasis on practical creativity in science seems to play against traditional Japanese cultural ideas of conformity to the group. To continue its national success, the Japanese government knows that it needs to educate scientific innovators to think independently and be prepared to challenge and take risks. At Tokyo Tech, Masaru Moriyasu believes these qualities are nurtured by hands-on work in the laboratory.
Although safety is of the utmost importance at all times, it is also important to provide practical experiments where the children can learn how to handle dangerous substances and to understand their mechanisms. It is essential throughout all aspects of science to experience things firsthand. If this is not done, it's just like never learning to ride a bike, because there might be the possibility of falling off and getting hurt.
一生自転車に乗れないままになってしまいますよね。だから少し手をこう手につけるとよいしょ、ちょっとオイルっぽいです。油です。オイリーね。匂いは。
Throughout Tokyo Tech Super Science High School, the desire to keep the practical and creative magic of science alive, to motivate as well as to inform students, has been a key driver in the school's development of its own curriculum. In their third year, students have to spend a majority of their time on identifying and completing a project study in their chosen specialist field. At Tokyo Tech, three-dimensional design, architecture, is taught as one of the fundamental themes of science and technology. These girls chose 3D design in their second year, and for their third year project study have collaborated on a project about the history and architecture of the Louvre Museum in Paris.
When I entered the school, I discovered that there were not many female students who pursue the hard sciences. I do think that not many female students pursue the sciences, but there are comparatively a large proportion of female students who join the field of architecture.
Susumu Monma is head of three-dimensional design.
3年生の特に
The third-year students' dedicated projects are thought out independently, based on the specialized architectural knowledge we teach in the second year and in the first part of the third year.
彼女たちのルーブル
The quality of the girls' model of the Louvre is very high. I have been a teacher for many years, but it is of the top quality. All students spend over 6 months on their project.
ですので、一生懸命約半年間やっております。
The students' ability to present their project and convey ideas is a central part of the third-year work at Tokyo Tech. In their project, the girls present the historical development of the Louvre's construction using their painstakingly researched model.
I originally wanted to pursue chemistry, but then I learned architecture in school and I enjoyed that very much. But my dream is to become a pharmacist.
I like making things and was looking at this school's homepage. There I saw some pictures of models and thought I would be able to do such things if I came to this school. So became interested and decided to take the entrance exam. As I started to come more in contact with learning about architecture, I began to think how much fun it was and really became interested in it. I'd like to leave my mark by leaving behind architecture which I've designed.
それがスーパーサイエンスハイスクールになって、変わっていくのは
In the Super Science High School, we emphasize much more the thought process, theory, and the function of the things we make. Also, debate about the experiments between the teacher and the students is encouraged very much. There is always a discussion among the students about each experiment, which sparks new thought and analysis. At the end, the results are presented in front of many
で
people.
今度はそれをたくさんの人の前で発表します。
The Super Science High School project and its emphasis on practical and creative approaches to science teaching addresses the shortfall of students interested in hard science. Professor Ichimura, in his double role as professor and head teacher, is sure this is vital to Japan's future.
Our nation have very small resources, so we'll have to produce talented, internationally active scientists and engineers. Unless otherwise, our nation cannot survive. That is a policy of the government.
This summer, I had an opportunity to teach at an elementary school. There, most of the students are very fond of science and nature, and they were fascinated and very enthusiastic.
授業すると「ワオ!」って言ってすごい感動してくれる。だから彼らはとっても。
However, as they move on to junior high school and then senior high school, the enthusiasm progressively diminishes. This seems to be the trend in Japan today. Therefore, we would like to preserve that interest, which is seen at the elementary school level.
一番いいのかなっていうふうに思いました。